Hey everyone. Today's lesson, we are going to move to section 7.3, which is about logarithms. So I know some of you came in after you took the ACT, those that were juniors that took the ACT back in February, and said there were things on their test that said logs or logarithms, and you didn't know what they were. So I want to give you just a really basic introduction to what logarithms are so that when you do take the ACT again, or for those that haven't taken it, you have an idea of what they're looking for. You also know how your calculator can help you. And I also, for those that are going on to take pre-calculus, this will give you a little bit of an introduction. So we're going to do about half of the introduction today, and then we'll do the other half with the next lesson. You will need a calculator, so make sure that's close by because the second part of this, I want to explain what calculator features can help you. So, first, to give you an idea what a logarithm is just another way to write something that is an exponent or something that's in exponential form. It is used a ton in science classes. So, you may have seen logarithms show up in problems or seen it, especially in like a chemistry class or a biology class. Logarithms are used to measure things like the pH factor of water, the magnitude of an earthquake, even like sound decibels. We'll use logarithms to measure them instead of using exponential notation. So if you've seen them before and didn't know really where or why, that's where they show up a lot. From a math point of view, I just want to make sure you're comfortable and know how to use them. So what you'll see on the screen is the way a logarithm works is that your log has a little number next to it where I wrote a b. This is called the base number. And then you'll have a number next to that. I call that the big number. I don't know if it has a name, but I've always called it the big number. And then you have what it equals. So in this case, I'm just being very generic. What that actually means, I tell students to kind of follow like the circular pattern or follow the cloud. It means that this base number, whatever it is, if I take it to this power, so to the y power, it will equal whatever the big number is. So you can actually take any logarithm and follow that cloud or that circle pattern, and you can write it as an exponent. So this statement and this statement are actually the same. This is called the logarithm statement. This is called the exponential statement. So for example, I have a few down here that you can see. If I wrote the log statement log base 4 of 16 equals 2, what that means is if I take 4 to the second power, I get 16. So again, kind of following that circle pattern there. So here's my exponent notation. 4 to the second power equals 16, which we know that's a true statement. Here's one that says log base 25 of 5 equals a half. What that means as far as exponent is if I take 25 to the half power, I would get 5. So again, seeing the exponent notation. Now you might be looking at it and going, I don't remember what the half power is. The half power is the same as square roots. So when I say 25 to the half power, what I'm actually saying is, what do I get when I square root 25? I get 5. And then here, sometimes you'll end up with ones that have ones and zeros. This log base 5 of 1 equals 0 means if I take 5 to the 0 power, again, kind of following that curve around, I get 1. So here's my exponential statement. And what you should remember about exponents is anything to the 0 power, you get 1. So those are kind of basic idea of how logs work. So what you're going to see, and I have my board here, so maybe you can see it, is a lot of times you'll be given questions like this where you have to solve your logarithmic statement. So this is saying log base 2 of 16 equals x. So what this means is, if I write it as an exponent, if I say 2 to what power, so 2 to the x power equals 16. My answer is going to be the exponent. So my answer is, what power do I have to take 2 to get 16? Some of these are going to be small and you'll be able to do them in your head. Other times you might have to grab a calculator and say, well, what is it? Is it 2 to the second power? Is it 2 to the third power? Is it 2 to the fourth power? It ends up being 2 to the fourth power. So your answer is actually just 4. Your answer is just the exponent. So if you have something like this, I'm going to show you a couple delta math ones as well to give you an idea. If you had a statement like this, log base 3 of 27, and you were asked to solve that, what you're doing is saying 3 to what power gives me 27. So again, thinking with exponents, so 3 to what power equals 27. There is a little guess and check involved, especially if the numbers are bigger. So 3 to what power? 3 to the first is 3, 3 to the second is 9, 3 to the third is 27. So your answer is 3, because again, you're figuring your exponent. So to show you what it looks like on Delta Math, you're going to have ones that fall into this category. They're called evaluate logarithms. Something like this. So it's going to ask you to find the value of log base 5 of 25. So what this is asking you is 5 to what power is 25? Again, having a calculator close by really helps with the guess and check. So 5 to what power is 25? 5 to the second power is 25. And you're going to put your answer in like that. The other thing you're going to be asked to do on Delta Math is you're going to be asked to answer some that are in logarithmic form. So this is saying log base x of 729 equals 6. So what you're going to write with this is you're going to follow that curve, that pattern. And so what this is saying is x to the sixth power equals 729. So writing it again as an exponent, so taking the base number to the power that's out there, 6 equals 729. This also might be a guess and check. You might have to say, well, is it 2 to the 6? Is it 3 to the 6? Is it 4 to the 6? The other thing you could do with this with the calculator is you could take both sides to the sixth root or the 1/6 power if you wanted to go through that way. It may be faster just to guess and check. I think it's 3 to the 6th power. So I'm going to grab my calculator and check. Actually, I have a calculator here, so I can do it here. So 3 to the 6th power is 729. So my answer would be 3. It's that missing part. In this case, the base is missing. And so you're going to have ones like that. They're very quick, especially if you have a calculator to check your work. You're not doing a lot of steps. It's mainly one step and a guess and check. So that's your basic logarithms and how they work. Always kind of follow that curve or that pattern. The other part today is that there are a couple special logs that we can do on a calculator. And I have them here. There are two special logs. So you might have looked at your calculator before and seen a log button and thought, well, what does that mean in terms of math? So the one special log is when it just has log and there's no base written at all. This is called a common log. The reason it's called a common log is because it's used very commonly in a lot of applications. It's the one that's used to measure like decibels of sound level or pH factor of water. It's probably the one you've seen more in like a chemistry book. When you have log written and there is no space number, it is understood to be base 10. So when no number is there, we understand that there's actually a little 10 there, we just don't see it. So if you had something like this and it says log of 100, what that's saying is 10, since there is a base of 10 there, to what power equals 100? Well, that one you could do in your head. 10 to the second power is 100, which is how you get an answer of 2. But let's say you have one you can't do in your head or you don't feel like doing it in your head. There is a common log button on your calculator. It is next to the 7. It actually says log. So if I want to do the common log of 100, I just type in the log button and 100 and it'll tell me the answer is 2. Same thing with the next one, the log of 53. That is not something you would know in your head. You just type in log of 53 and it'll give you the answer. Nice, same thing here, log of 272, log of 272. And you get 2.43 and so on and so on. You get a lot of decimals for these if they're ones that don't work out real nice. So that's called common log. And so if you see an log and you don't see a base number, it is just understood to be base 10, which is the easiest base to work with. The other special log is called natural log, and it's the button that has the L and the N next to it. We've actually hit that button when we were working with E before. So on your calculator, it is the button right underneath the log one, the one that says LN. That's called natural log. It is used a lot in nature applications, which is where it gets its name. Natural log is used a lot in biology classes. For this one, there is no base written there, but the base is understood to be that number E that we just spent a couple days working with it. So it has a base of E. Now, the nice thing about natural log is it has its own button. So if I want to know the natural log of 7, you just type in the ln and then the 7, and you get, again, you get a lot of decimal answers with these because E is a number that goes on forever. ln has the same deal. If I want to know the natural log of 89, I would just type in ln 89 and get my answer. Now, if it has a natural log in it, let me move this up a little bit. If it's the natural log of e to the fourth, and you can put this in your calculator, so you can type in natural log ln and then hit second ln to get the e to show up, and then 4, you actually get 4. And the reason you get 4 is because what this is saying is e to what power gives me e to the fourth power. So when you have this natural log next to an e, it's kind of like they cancel each other out. They're like inverse functions. If you don't remember that, it's no big deal. Any natural log one can always be put into your calculator and you'll get 4. So that is just a really basic introduction. If you're taking an ACT test, if you're taking a placement test and you see logarithms show up, either they're going to be really basic ones that you can do in your head, like what we did at the beginning, or they're going to be common log and natural log, which have buttons on the calculator. So you have the log button, you have the ln button that we can use for that. So, what I'd like you to do now for an assignment is I want you to go through the Delta Math assignment, and we're going to just stick with really basic ones that are asking you to evaluate logarithm statements and with like single number answers. And that will do our basics. Next time, we're going to come through and we're going to look at a little bit more applications and rewriting with that. Have a great day, guys.